Hello everyone, welcome back. We'll continue our discussion on statistics for data science. Okay, so far we have covered about the data types, then measures of central tendency and measures of variability. And now we'll start with probability distribution functions. So we can actually plot some graphs, okay, which will actually calculate the probability of happening. So it describes the likelihood of an event or outcome. Okay, so say my marks in the exam. So whether I will get less than 50% or greater than 50%. So we can just calculate that. Okay, there is a chance that I may get greater than 50%. Is there is some 80% chance that I will get more than 50, and the rest part, that is the 20% chance that I may get less than 50. So whenever we calculate probability, there can be different values for which we calculate the probability, but the sum of the different probabilities of different possible values always add up to 1. So that's why when we draw some probability distribution function, then it can be of different shapes depending on the data and the type of data available with us, but the size will always be the same. That means the total probability in a distribution always be 1. Okay, and of course there are some different shapes for continuous and discrete data. So there are different types of probability distribution functions available, but here we'll just give you some basics and we'll discuss about only two probability distribution functions. One is for continuous data and one is for discrete. So the first one is probability density function. It represents the probability of a given range of values occurring. So this graph is drawn mainly for continuous data. Okay. So say the weight of a person. Okay. The weight of a person may be from 50 to 100 kg, and you know that the weight can be anything, means it's like 50.001, 50.002, then 51.101. So a lot of possible values, right, in continuous data, and it is actually not possible to find the probability for each and every value possible, right? In the continuous range there can be numerous number of values, and it is actually not possible to calculate or possible to plot this type of continuous values. So instead of plotting each and every value in a continuous data set, what we do? We take the range of values maybe. So in our case, maybe we can calculate that, okay, what is the probability that the person's weight is from 50 to 60 kg, and 60 to 70 kg, 70 to 80 kg, 80 to 90 kg, and 90 to 100 kg. So there can be numerous values possible for the person's weight, but I can divide it in 5 ranges and I can calculate the probability for these different 5 ranges. Okay, so if you just follow this graph, here also I have tried to do the same thing. So maybe this range of values, if you take this peak one, so for this range of values, this is the probability. So that way I can just take different ranges of values and I can calculate the probability. And when these boxes are drawn, means these probability calculations, then this type of plot can be drawn. So this actually gives you some idea about how the the probability is moving for different range of values. So this is called probability density function, and there are different versions of PDF for different types of values. We can draw different types of PDF. Okay, then comes probability mass function. This probability mass function is mainly used for calculating the probability of from a discrete data set. So discrete data set means, so here if you can see the graph, here say the possible values are 0, 1, 2, 3, 4, 5, 6. Okay, 7 possible values, and I can calculate the probability that, so what may be my next value from the set of values. Okay, so here you can see different probabilities are plotted, like the possibility that the value may be 0 has some probability of 0.1, the value may be 1 has the probability of 0.2, the value may be 2 has the probability of 0.3, and so on. Okay, and the total probability will always come as, okay. So that is the way I can draw the probability distribution function for the discrete data set. Okay. Next we come to measure of location. So we have seen central tendency measurement, we have seen variability measurement, and location measurement means when there are many people at a place or many marks. Okay, so where I am, that is the important thing. So if in your class you have many students, so you may be interested not only your marks percentage, but where you are among the class. So say if you get 90 percentile, so 90% you understand. 90% means if the exam happened, the total marks was 100, then you got 90. That is 90%. But what is 90 percentile? If I say that I got 90 percentile in the exam, what does that mean? That 90% of the students got less marks than me. So if it is a sorted data set of marks, say for there are some 500 students in your class, if all the marks are sorted in an order and if you got 90 percentile, that means that there are 90% of the total students who got marks less than you. So you can understand that okay, there are 10% of students in the class who perform better than me. So that is the calculation of percentile. Then comes quartile. So what is quartile? It is a special type of percentile which divide the data into quarters. So it is nothing but in the percentile you have all possible percentiles from 1 to 100. So 25th percentile is known as quarter 1 or Q1. 75th percentile means Q3 and 50th percentile means Q2. 50th percentile also can be represented as median, because what is median? Median is the middle value of a sorted data set. So if you get 50 percentile in an exam, what does that mean? That 50% of students in your class got less than you and 50% students got more than you. That means you are in the middle position in the class. So your marks is actually the median in the class. We can say 50th percentile or Q2 or median. All these three are same. So that is the calculation of quartile, and there is interquartile range, which is the difference between Q3 and Q1. Okay, so interquartile range is nothing but the difference between Q3 and Q1, that is the IQR, and it helps in determining outliers. So what are outliers? Outliers are some data points which are actually not matching with the rest of the data set. Is kind of, you can say, outsiders or wrong data. Okay, so we'll have some outlier calculation in the coming session, so it will be more clear to you. So for location measurement we are using these measures. Okay, now we are moving to another concept which is called covariance. So what is covariance? It is the measure of association between two or more random variables. So here for simplicity we will take two variables and we are just trying to find the relationship between them, that how they are related. That is covariance. So there can be different possible covariance values. Okay, if the value is 0, that means that these two variables don't vary together, means their increment or decrement don't have any relationship, then the covariance is 0. When the covariance is positive value, any positive value, then what does that signify? That these two variables tend to vary in the same direction. Means say there are two variables x and y. So I have to calculate that if they are related or not. Means if x is increased, what happens to y? Okay, say if we take meter and centimeter. Okay, so if you know that 1 meter means 100 centimeter. So in that case, if you calculate, like say 1 meter equal to 100 centimeter, and if you just multiply 1 into 5, so 5 meter means 500 centimeters. You will always find that whenever you are increasing the meter value, the centimeter value is also increasing, right? So that means they are related and they are moving in the same direction. As you increase meter, the centimeter value is also increasing. So they are just closely related, right? Means it is like increasing one's value also increases the value of the other one. That is the positive covariance. Next comes negative covariance. When two variables vary in opposite direction, that means that they are related, but when you say increase x, y is decreasing, just the opposite direction, but they are related, then it is the negative value. And how do you calculate covariance? This formula is given. Covariance of x, y is, x means say one data set, one set of data values, y is another set of data values. And how do you calculate covariance? First of all, this xi minus x bar. So what is x bar? X bar is nothing but the mean of the values. Say there are 5 values in x and 5 values in y. Okay, so x bar is the mean of the x data set, y bar is the mean of y data set, and what we do, we just calculate the difference, okay, between all the values and the mean. Okay, so if I just go to this Word document, say I have values some 10, 20, 30, 40, 50. Okay, if this is your x data set, then what I am doing, first of all I am calculating the mean of x, and then I am calculating the difference between say 10 minus x bar, 20 minus x bar, 30 minus x bar, 40 minus x bar. This similar way I have another data set y, and I calculated the mean and I find the difference. And then for each multiplication of differences, that means say x1 minus x bar into y1 minus y bar plus x2 minus x bar into y2 minus y bar, and so on. We just calculate the summation of that difference and then we divide it by the number of elements. So that is the covariance calculation. Okay, so covariance can help us to understand that if two sets of data are related to each other or not, means if they have any relationship when they are increasing or decreasing. Okay, but the problem is that here we can only understand that whether they are related or not, whether they have some association or not, but we cannot understand the strength of the relationship, means how strong is the relationship. We can understand there is a relationship, but how strong is the relationship, that we cannot understand from covariance. Okay, for that we have another measure that is called the correlation. So it is the measure of the degree of relationship between two random variables. So here I am not only calculating that whether they are related or not, but I am calculating that how strongly they are related or how weakly they are related. So there are three possible values of correlation. First one is 0. 0 means no linear relationship between the two variables. Okay, so you know the formula I have given you. So correlation of xy means covariance of xy. That first you can calculate the covariance and then you divide by standard deviation of x into standard deviation of y. Okay, this is the standard deviation. So this value will have no unit because you are dividing this covariance divided by this. So this correlation actually has no unit and it ranges from -1 to +1. Okay, so the middle value is 0. So if the correlation value is 0, that means there is no linear relationship between the two variables. When it is positive, that means that two variables move in the same direction. Okay, and above all, as the value will be ranging from something more than 0 to +1. So when it reaches +1, that means it has a perfect relationship. And if say the value is 0.1, 0.2, 0.3, 0.4, 0.5, that means that there is some relationship, but that is not perfect. It is kind of some better relationship, but it is not the perfect relationship. So you can understand that the correlation value can be from 0 to +1 in one direction, and when it is +1 we take that it is a positive relationship and it's a perfect relationship. That is, they are moving in the same direction and they have been a perfect relationship. And when the correlation value is negative, it signifies that these two variables move in the opposite direction. And here also the value can be from 0 to -1 in the negative direction. So when it reaches -1, that means it's a perfect relationship, and if it is between 0 and -1, that means it has some degree of relationship but not the perfect. So through correlationship we can actually measure that whether they are related or not, and if they are related, then what is the degree of relationship between them. Okay, so that is correlation. So we'll stop here, and we'll continue in the next session on statistics only. Okay, so for now, thank you.